Hi, this is Aditya Ara. Welcome to the class AUV 835 Vehicle Electronics. My project for the class is a tachometer using Hall effect sensor with LED indicators. Hall effect. When a magnetic field is brought near a conductor carrying current, a voltage difference is induced. This voltage difference is directly proportional to the magnetic field around it. A Hall effect sensor uses the exact principle to detect magnetic field around it. In this experiment, I'm using a MIDAC to acquire data from the Hall effect sensor. The Hall effect sensor operates at 5 volts, so I'm using a voltage regulator to constantly supply 5 volts to the sensor. I also have a low pass filter in the circuit to prevent digital noise. I also have an LED array which connects to the digital output of the circuit for indicating speed. The experimental setup. I used a prototype breadboard to initially assemble all my components. This is how it looks. The sensor needs a triggering system to operate, so I used a motor connected to a potentiometer as an input to the sensor. A magnet is also attached to the end of the motor for the Hall effect sensor, the major components in the circuit. Hall effect sensor. This is a latching type Hall effect sensor. A voltage regulator which supplies 5 volts, a resistor, a capacitor, and an LED array. This is how all the components look on my breadboard. The output from my Hall effect sensor is a square tooth wave. When there is changing magnetic field around the Hall effect sensor, it creates a square tooth wave with a certain frequency. This frequency is directly proportional to the speed of input. So we can write a LabVIEW program to calculate the RPM using the frequency output from the Hall effect sensor. The first part of my LabVIEW code is to acquire the data from the Hall effect sensor. This captures the data as frequency from the Hall effect sensor. This part of the code converts the frequency into the RPM, and this part of the code is responsible for controlling the LEDs. The front end of the code has a tachometer interface. There's an analog tachometer readout with bunch of LEDs beside it and a digital one too. Here you can see me controlling the speed of the fan using a potentiometer. This in turn showing out the speed readout in the interface as well as the LEDs on the breadboard. These LEDs are programmed to glow incrementally. For every 500 RPM, an extra LED grows. Thus, the first LED indicates RPM lower or equal to 500, and the second 1000, and so on up till 3000. These LEDs can be programmed to glow at different RPMs, which would aid the driver using manual transmission to have an efficient shifting pattern. Thank you.